I've got some handy dandy little whiteboard notes here, so we're gonna go over it. First off, I just want to say that these are the three main Great Pyramids. We've got Khufu, Khafre, and Menkaure. So this is the Great Pyramid right here, Khufu. It's the biggest one. As you can see here, we've got in feet and meters how tall they are, and then in meters for all of them. The biggest one I have in feet as well for the length of them, like one of the sides, how long it is. We also have here the angles of the bottom here, that's symmetrical obviously, and then this top angle. And before we really get into these notes, I just want to say that it makes sense that, especially just let's talk about this Great Pyramid, the biggest one, how it is encoded with this mathematical information. This is what this video is going to be about. We're going to get into the details, but the reason why this is obviously true and this is obviously the case, I mean, once we get into the math, it's undeniable, but it makes sense that geometry is the language of the universe. I might do a video on this in the future, just kind of getting into this concept more in depth. These advanced races, these different types of beings, they don't speak our language, they don't speak our words, they don't speak our numbers, they don't speak our units of measurement, but ratios in geometry, certain angles, certain ratios of height and length, etc., create these sacred geometrical shapes. So whoever built the pyramids knew this, understood this, used this to the full extent to encase so much information and synchronicities. Obviously, it's not coincidence, the synchronicity, but then it begs the question as to why did they do this? I feel like the Great Pyramid, you know, who knows what technology it had about it, inside of it, what it was made for, but the structure itself is a representation really of the earth. Because if you look at a map of the world, where is Giza? It is in the middle of the earth. It's the most amount of land through the middle of the earth. That's where it is. The most amount of land through the width of the earth. That's where it is. It's right boom smack dab in the middle of the earth, and it's a representation of the earth. Near the end of this video, we're going to get into how the circumference of the earth comes into play, even like the distance from the earth and the moon comes into play with the Great Pyramid. But first, I want to talk about these mathematical constants and these important ratios that are encoded in the Great Pyramid. First of all, it's found on this latitude, 29.9792458 degrees north latitude. So obviously there's lots of other things running along this latitude line, but that's one of these very important points. So there's a ton of other stuff on this line. There's a line all around Earth on this latitude, but that is the speed of light. Meters per second speed of light, 299,792,458 meters per second. Meters was not invented yet, that form of measurement, during the creation of this pyramid. So that is weird. If you get into the meter calculations for these ratios, they are actually extra special compared to any other form of measurement for these calculations. I didn't get into that during the math for this video, but the fact that the speed of light is meters per second is kind of wild to me, because I've seen other videos of people talking about how meters in specific are just even more mind-blowing with the golden ratio and things like this coming into play with the Great Pyramid. Anyways, just the ratios in general, because ratios, the unit of measurement doesn't matter for ratios because that's what a ratio is, okay? It's more like geometry. So we've got, I used feet for the length of one of the sides of the base of the pyramid, 755.79 times 2 to get the north side and the east side, to get, you know, part of it. So if you're looking at it from this way, equals 1,511.58. Divide that by the height of the pyramid in feet, because you have to use the same measurement. If you're picking feet, you go with feet. You get 3.136 or 3.14, which is pi, and pi is the circumference of a circle divided by the diameter of the circle. That's one example of pi being used in the Great Pyramid. And that's one of the most obvious calculations that you would do, is looking at the pyramid this long way and then the height of it, divide it. That's a ratio. it's pi. So then we've got in the high chamber of the pyramid, it's like two squares put together. It's a double square, which has the golden ratio in it, okay? And the golden ratio is 1.618. That's what this spiral is. That's what this kind of like circle with the capital I through it is. I looked a bit into the golden ratio because honestly, I wasn't familiar with all the numbers used into it, but basically it's when you divide 5 by 3, when you divide 8 by 5, when you divide 13 by 8, when you divide 21 by 13, 34 by 21, 55 by 34, it creates, I mean, in geometry, this kind of spiral shape, which fits into this double square here. It creates this perfect golden ratio, whereas if you used other numbers, it wouldn't be so perfect. So lots of thought went into this pyramid, even this chamber. And over here, I just kind of drew an example of how you have pi times the golden ratio, pi times the golden ratio, where this middle part is for the height of the pyramid. If you have the height of the pyramid as a unit of 4, then you have pi and the golden ratio used throughout that ratio with the Great Pyramid. So that is pretty cool. If you take 51.84, which is the degree of this angle here, the bottom angle of the pyramid, you multiply it by 4 for the 4 sides, you get 207.36. If you divide that by this other angle here, the top angle, 76.3.30, you get 2.7176 or 2.718. Simplify it. That is Euler's number, which is used in compound interest. This is another mathematical constant, this E symbol. I had never even heard of that before, but this is another advanced math constant number that's very obvious just simply looking at the angles in ratio to each other of the Great Pyramid. Here's another one. You take 146.6, get more exact. We're using meters now for this different calculation because we can do that. Divide it by 230.4, getting more precise meters for the length of it. That is the height to base ratio. You get 0.636. It's a little different because I did the calculations for the other two Great Pyramids, but the Great Pyramid in general, it is actually very similar for those ratios, which it kind of has to be to have a pyramid. But that is the area of a Kepler triangle. A Kepler triangle is a right-sided triangle where the side ratios are the square root of the golden ratio. So that is another like amazing mathematical thing within the Great Pyramid. Now we're gonna get into how this correlates more with the Earth, because this is my favorite part of the math of the Great Pyramid. If you take the Great Pyramid and you blow it up massively, you multiply it at a certain ratio, the Earth will fit in it perfectly. Obviously, you can blow it up to whatever size you want, but the fact that the circle of the Earth fits perfectly in it is pretty freaking cool. And there's also studies that show that if you take the Earth and you put the moon directly on top of the Earth, the ratio of the exact sizes of them, and then you take the ratio of the Great Pyramid, put it halfway on top of Earth, and then the bottom half of the moon, and it fits perfectly as well. If you take the Great Pyramid, put the Earth inside of it, and then put the moon inside of it on top, the sides of the moon are going to kind of go over a little bit, but it fits right there at the top of the pyramid so freaking perfectly. And the golden ratio, the two squares on top of each other that form the golden ratio, this guy right here, he's so freaking talented with a compass, so you should totally check him out. If you take the height of the Great Pyramid in meters, multiply it by 43,200, which is the axial progression of the Earth. It's a multiple of 72. You multiply that by the height of the pyramid, you get about the polar radius of the Earth, which the polar radius of the Earth is 6,356,752.3141 meters. And the actual number you get when you do this math is 6,333,120 meters, which that's a huge number. So this difference is well under 1%. Also, if you take the perimeter, okay, you have the base, multiply it by 4 sides, you get 921.6 meters, 928.3 E370 with the cladding around it, multiply that by 43,200, you get the equatorial circumference of Earth, which the actual equatorial circumference of Earth is 48,002,548 meters. The actual number you get when you do this math with the cladding is 40,121,438.4 meters. Another calculation based off the Great Pyramid that will get you Earth's equatorial circumference as well as Earth's polar diameter is if you calculate the seconds in a day. So take 60, multiply it by 60, multiply that by 24. You get 86,400 seconds in one day. Keep that number in mind. We're going to multiply it by the height of the Great Pyramid, 482.7575 feet. You get 41,710,248 feet. That equals 7,899.668 miles. That is Earth's polar diameter. Earth's actual polar diameter is 7,900 miles. That is so extremely close, creepily precisely accurate. Then if you take the north and east sides, like the base of the pyramids, just take two sides of it, for example, north and east, you have 760.879 feet, 760.748 feet. Add those together, you get 1,521.627 feet. Then multiply that number by 86,400, which is how many seconds are in a day. You get 131,468,573 feet. That is 24,899.35 miles. Earth's equatorial circumference is 24,901 miles. Don't get it twisted, it's all interconnected, and none of this is a coincidence. There's way too many things for it to be a coincidence, and the fact that all of these are true makes it even more creepily precisely accurate. Another awesome thing you can do with the pyramids, take the length, 760 feet plus 760 feet, just that basic math is 1,520 feet, or more precisely, the east and north sides added together actually is 1,511.31 feet, which 1,509 feet per second is the Earth's rotation at the equator. Best believe there is going to be more Great Pyramid videos to come. There's going to be videos explaining how the Great Pyramids correlate to these other pyramids around the world because there are so many. But I just wanted to do really my first video on the math of the Great Pyramid. Let me know what you guys think. I have a tattoo of the Great Pyramids on my wrist. It's kind of hard to fully twist my wrist so you guys can see. It looks lopsided here, but in real life it is straight. And then I just got this new tattoo, this Syrian symbol here, the triangle with the swirls in a couple different shades of blue. So I appreciate you guys so much. Peace out.